Right, here's a classic linear programming problem. So what we need to do in linear programming, a quick review, is we're going to find constraints, and that's what these 3 bullet points are here, is constraints. And then we're going to create a profit equation, and we're going to use those constraints to find possible points that could maximize our profit equation. And then when we find those possible points, we're going to choose the highest one because that's the profit we want. So what we're doing here is trying to find out how many t-shirts versus sweatshirts we should sell. And the little tags here give us the information we need. It says it takes 10 minutes to create a t-shirt, and it takes 30 minutes to create a sweatshirt, and it tells us that the supplies of a t-shirt cost $4 and the profit is $6, and it tells us the supplies of a sweatshirt cost $20 and the profit is also $20. So we're going to put all of those to good use for us as we come up with equations. So I'm going to do these color coded. First of all, we know that x and y both have, well, let's name our variables. X is the number of t-shirts that we make, and let's call y the number of sweatshirts. Okay, so we know that x and y both have to be greater than 0, and that means that we're just going to be in the first quadrant on our coordinate plane. So we're only going to be dealing with something in there. So I won't even graph those. We'll just keep that in mind. Next, we know right here, I'll use red for this first one, that you have at most 20 hours to make the t-shirts. Well, this is in minutes, so let's convert 20 hours to minutes. So 20 hours means 60 times 20 is 1,200 minutes, and we know it takes 10 minutes to make a t-shirt. So 10 times however many t-shirts we make, which we called x, plus, and we know that it takes 30 minutes to make a sweatshirt, so 30 minutes times how many sweatshirts we create, which is y, has to be less than or equal to 1,200, because that's how many minutes we have in total. That's our first constraint equation. The next one, it says we can spend no more than $600 on supplies. So we know that it costs $4 for every t-shirt that we need for the supplies, and it costs $20 for every sweatshirt for the supplies, and we know that has to be less than or equal to 600. And then we also know, I'll do this one in light blue, that you can spend we need at least 50 items. We need to have at least 50 items. So we know that x plus y, which is the total number of items, has to be greater than or equal to 50. So those are our 3 constraint equations, and now in order to best solve this problem, well, sorry, let me write one more equation. Let's write the profit equation. The profit is going to equal, it says here that we make $6 profit on a t-shirt and 20 on a sweatshirt. So 6 times x plus 20 times y is going to be my profit. You'd like to say, oh, I can make as many sweatshirts and as many t-shirts as I can, but there's constraints. There's constraints that you have that limit the amount of money we can spend or the amount of shirts we can make. There's always constraints in the real world. And so we're going to use these constraints and the profit equation. We're going to find out what the best possible scenario is. We're going to say something like you want to make 20 t-shirts and 50 sweatshirts. That's how you'll maximize your profit. Okay, that's what we're after. So to do that, first of all, we're going to convert each one of these constraint equations. To be able to graph it, we're going to find, the best thing to find are the intercepts, the x and y intercepts. So remember to do that, I plug 0 in for x and solve for y. So when I plug 0 in for x there, I just divide 1,200 by 30, and now we get 40. So there's one of our points. There's our y intercept for that point. And then to find the x-intercept, you plug 0 in for y right here, and you solve for x. 1,200 divided by 10 is 120. So let's go and let's put these on a graph. Well, let's not put them on a graph quite yet, because it's best, in order to know what interval length to make your graph, it's best to find all of your points before you start graphing one of them. The next one, we're going to do the same thing. We're going to plug 0 in for x. When I plug in 0 for x, I'm just dividing 600 by 20, and that means that zeros cancel like 10s cancel, and that gives you 30. And then we're going to plug 0 in for y, same deal, and solve for x. 600 divided by 4 is like dividing 600 by 2 twice. So it's 300, and then it's 150. So 150, comma 0. No need for a calculator if you don't need one. Try not to use one because it takes too much time. And then this is easy. It's just 0, 50, and 50, 0. So I can see my largest x value is going to be 50, and my largest, y value is 50, and my largest x value is 150. So when I'm making this graph, I'm going to keep those two things in mind. 150 is my largest x value, so you'll notice that I have 5 larger intervals here, 3, 4, 5. Well, I really have 6, but I think on the worksheet that I saw, I really only had 5. So let's make each one of these 150 divided by 5 is 30. So let's make each one of these 30. 30, 60, 90, 120, 150. Again, I'm choosing that because on the worksheet that I saw, they only had really room for 5 of those. And then let's do the same here. It's always best if you can keep it as a square matrix, meaning the x and y dimensions are the same. Otherwise, it's warped a little bit, and you won't get a sense if you're doing it right sometimes. Okay, so let's do these things. Let's do the red one first. The points are 0, 40, and 120, 0. 0, 40 is right about, let's see, 1, 2, 3, 4, 5. So that's 30 divided by 5 is 6. So each of these is 6. Each of these small tick marks is 6. So 40 is going to be right about here. And 120, 0 was it? Is right about there. It's exactly there. So my red line looks like this, and it's shaded down. I won't bother shading it yet because then I'll have to erase it. I'd like to just wait till the end to shade all of it. For the green one, 0, 30, and 150, 0. 0, 30 is here. 150, 0 is here. That was easy. Let's take our green line and let's draw it right between there and there. The next one, the light blue line, tells us 50 and 50. So 50 is about, let's see, what was that, 40? 50 is somewhere about here, and 50 is somewhere about here. Again, these are just rough. It's okay if it's not exact because we're going to find exact values in a second. Now, where was the green one shaded? You remember that that was a less than or equal to sign. So that one was shaded down, and the blue one is a greater than, which is shaded up. So the green one, the blue one is shaded that way. The green one is shaded that way. So the feasible region is right there. Those are all of the things that I can consider as potential things that I can plug in. Why? Because if I picked a number out here, that doesn't satisfy all of the constraints. If I picked a number here, or here, or here, or here, anywhere but in that shaded region, the constraints aren't satisfied. All 3 of the constraints, 5 really, but all the constraints need to be satisfied for it to work. Okay? So now the next step is to find out what those values are. These different points right here, we got to find out what all of those values are. So I'll do this in black so you can see what I'm doing. That point, I need to see what that point is. I need to see what this point is. I obviously can see what that point is. That point is 120, 0. And I obviously can see what that point is, which is 50, 0. So really I only have to find 2 points, and then I'm going to plug them in to find out which one is the biggest profit. So here's my x comma y, and here's my profit. So if x is 120 and y is 0, what will my profit be? Well, remember what your profit was. It was this equation, 6x plus 20y. 6x plus 20y. So if I plugged in 120, 0 to that, I would get 6 times 120, which is $720. That's not bad. If I plugged in 50, 0, I would get $300. Well, that's not the right answer because I want to maximize my profit. So we know it might be 120, 0, but let's find these other 2 points. And how do we find those points? Well, we find out where those 2 lines intersect. So the blue and the green line, I got to do that first. the blue and the green line, where do they intersect? So it's 4 plus 20, 600. I'm really just 4x plus 20, y equals 600. I'm really just finding where the lines intersect. So I don't use the inequality, I use the equal sign. X plus y equals 50. So let's solve that system. How do I do that? Multiply this by -4, right? So that's -4x minus 4y equals -200, and then add straight down. This is called solving by elimination. So what's 400 divided by 16? Which is 25. Well, if y is 25, then so is x, because we can plug it into that one. So x and y are 25. So let's write that as another option, 25 comma 25. And what would the profit be? Plug in 25 here and 25 there. Figure out what your profit would be. Let's see, what is that? 150 plus 500. Is that right? 650. 650 is not bigger than 720. So that wasn't the right answer. How about this last point right here? Let's find it. That last point is the intersection of the green and the red. So let's go back, green and red. It's these two. So 10, 30, 1200, 10x, plus 30y is equal to 1200. Again, I'm not doing the inequality, just the equal to is fine. And the green one is 4, 20, and 600. 4x plus 20y equals 600. Now to solve this system, it's going to be a little bit trickier because I don't have multiple. One of them isn't really a nice multiple of the other. So we're going to have to multiply both of these by something, right? Let's multiply this by 5, or -5, and let's multiply this by +2, so that I get 20. 20x plus 60y equals 2400. And this one is -20x minus 100, y equals -3000. That cancels. That becomes -40y equals -600, which means y equals, what is that, 15? Y equals 15, and if y equals 15, plug this back in there and solve for x. That was 302 divided, what would x be? 200 times 15 is 20 times 15 is 300, right? 300 divided by 4 is 75?
Yep.
X equals 75. So let's try that point out. 75 comma 15. 75 comma 15. If I plug 75 in for x and 15 in for y, what do I get for my profit? Which is 750, and that is the highest one. That's higher than 720 and 650. So what you would write is the max profit of $750 when you sell 75 t-shirts and 15 sweatshirts. So it's a long problem. There's lots of pieces to it, but none of them are very difficult if you have practiced this a few times and get it.